For this problem, what we have to do is we have to figure out the length of a line segment, the one I'm going to be highlighting here in green. Right, there's two different ways you can certainly do this question. First off, you can do the Pythagorean theorem, or you can use the distance formula. We're going to use both for this example to show you that it doesn't matter which one you use, you should be able to get the same answer as long as you've done it properly. The Pythagorean theorem requires a right angle triangle to work, so if you connect the endpoints like this, you will get a right triangle. After you've got that set up, all you need to do is count the squares that each side occupies. So the height of the triangle is 3 squares. On the bottom you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 squares for the base. So here's a triangle again without the grid. Here's the formula we're going to use. We're going to use a squared plus b squared is equal to c squared. C being our hypotenuse, which is what I've highlighted in yellow. All you need to do is plug in the sides of, with the information we do have. So that'll be 9 squared plus 3 squared is equal to c squared. So 9 squared is 81, 3 squared is 9, so that's going to be 90. But be careful, because c squared is 90, and we just want c. So you have to take the square root of this in order to make that work. So c is going to be root 90. Now this is an entire radical that we can reduce to a mixed radical. If you pull this apart, 90 is 9 times 10, and you have a perfect square of 9 in there. You can bring that out, and so your answer should be 3 root 10. Going back to the diagram, we'll see that both of the endpoints of this line segment have coordinate points. These are going to be useful for the distance formula. Here's the distance formula, and I've written out the 2 points using different colors so you can see where things are going to be placed. Let's start with A. I'm going to suggest we do have x2 and x1 and y2 and y1 to designate your points. Since it's A, we'll say this here is point number 1, and B is point number 2. Remember, of course, the first number in each pair is the x, and the second one is the y. So you can write those ones out as well. This will be x1, this will be y1, this will be x2, and this will be y2. When placing these points in the formula, here's what we start out with. B, of course, we designate as our point number 2. So I'm going to place the points right there. So we've got 3 because it's x2 and 1 because it's y2. A is, of course, our first point. That's what's going to be subtracted. So it's going to be -6 for our first bracket. And for our last bracket, it's going to be -2. Now, of course, these are going to be subtracted. Let's start with the first bracket. What we have is 3 minus a -6. Remember, you're subtracting a negative number, so you're essentially just adding it. So the first bracket is going to be 3 plus 6 squared. So that's 9 squared. The second bracket, you have 1 minus a -2. So that is going to be 3 squared. This should start to look a little bit familiar to you. Once we've worked this one out, you've got 81 plus 9, which is going to be root 90. Now if you remember from the last problem, where we used the Pythagorean theorem, this turned out to be 3 root 10.